Hello, everyone. I am pleased to welcome you to this wonderful event, which marks the climax of the Hamoye Summer Internship, the June 2021 cohort. My name is Chigozem Bon, a data scientist at the Hamoye AI Lab, and I would be your host. I am exhilarated to be part of this remarkable event today. I'm joining this call from Lagos, Nigeria, and trust me when I say that there is no better way to make a great weekend than enjoying this stupendous presentation by our true MVPs, our beloved and dedicated interns. Our interns have worked within a learning community on different data sets, applied several machine learning and data analysis tools, and have come up with solutions which I can't wait to see them show to us. They have tested and validated their solutions in real life, and here today, they are ready to blow the minds of our incredible judges and every one of you here present. Our judges are prestigious machine learning professionals that have coordinated and mentored early professionals to humongous success. Allow me to introduce to you Mr. Charles Adity, a man who in himself does not need any introduction. His work over the past 15 years in the industry has enough volume that can cause a tremor. Charles is the co-founder of Maven Code LLC, a big data expert, a consultant, a mentor, and today he's going to be one of our judges. Welcome to the grand finale, Mr. Charles. Our second judge is one whose energy and innovation and innovative mind has fueled the industry in the past 2 years. He started as a computer scientist, summa cum laude, then a computational thinking and data science intern with yours truly, Hamoye. And today he's a hotshot with Maven Code LLC and Koteri AI. Highly distinguished interns, participants, allow me to welcome Godwin Ekainu. Mr. Godwin, it's great to see you with us here today.
It's nice being here too. Thank you for having me. Thanks for having me.
You're welcome, Mr. Godwin.
Mm.
Well, before we proceed with the presentation proper, there are a few housekeeping rules that you are meant to abide by. But before I read out those rules, there's an intern of us that caught our eyes during the course of this internship. This is none other than Sumitra. Sumitra worked on a project that could predict the availability of gold. And it might surprise you to know what 1 gram of gold costs in the markets right now. It's about $58.48. So permit me to have Sumitra online right now and ask her a few questions. Sumitra, are you here with us? Sumitra? Okay. All right, so I'll be moving on to the housekeeping rules.
Hello.
Sumitra, hi.
Yeah, hi.
Welcome, Sumitra. So your project has been really eye-catching, and I will want to know what are the challenges that you faced coming up with this lovely project, and how were you able to overcome this successfully?
Yeah, actually, this is a very new project. So when I started this project, there are like many challenges. Like first is data. Data collection has been a very problematic task for us because we cannot find an open source TIFF images. So it took a lot of time for us for processing the data and working with the data. And the next is the model running. So it takes a lot of time to get the features of the images. So these two we have faced, and we run on some algorithms. As we don't have enough time, we actually run on some classification algorithms only. So these are some of the challenges we faced, but I think we have overcome it, me and my team.
That's a good one, Sumitra. I look forward to seeing what you have for us today.
Thank you so much. Yes.
Now, a few housekeeping rules before we proceed with the presentation. Should you need to speak, please raise your hand and you'll be unmuted. Presenters for every group are expected to use their full names as their Zoom display name. This is to enable us to identify them easily and grant them screen sharing permission. You can post your comments, ask questions, and share how you feel on the chat boxes down below here on Zoom, on YouTube. And my best wishes to the presenters today. Now to the presentation. Mr. Charles and Mr. Godwin, do I have your permission to proceed?
Yeah, sure you do. You can go ahead.
Thank you very much. All right, now for the very first group we have here, Analysts 01 stock performance. They worked on the project on stock performance. We have here with us Baderinwa Adedamola and Isaac Ojo to be presenting group 1.
Good afternoon, everyone. My name is Baderinwa Adedamola.
Good afternoon, Isaac. Baderinwa, welcome. What about your co-presenter? Is he here on ground?
I'll be presenting alone. But I think he's on ground.
All right. So what are we expecting from you today? Hope you're ready to blow our minds.
Yes. Without wasting much of our time, let me just go straight to what we have for you.
All right. Your time starts.
Okay. Okay. Good afternoon, everyone. Once again, I'm here on behalf of Analyst 01 Data Analysis Internship Group, and we did a data analysis on finance stock performance. So, okay, understanding stock performance. To understand stock performance, you have to know the keyword stock analysis. It is used to obtain accurate information about stock performance. And what is stock analysis? Stock analysis is a method for investors, traders to make buying and selling decisions. And they do this by studying and evaluating the trends of prices of stocks over the years. That's just a summary of what we have on the screen. So the project overview, our stock performance analysis will primarily involve comparing a company stock current state to its historic trend to give an investor a sense of what whether the company is growing, stable, or deteriorating. And it also gives them a analyzed, informed decision so that they can make recommendations on the stock they can buy. So the principal aim of this analysis is to give investors a comprehensive data to make informed decision on stock purchase, like I said earlier. So project hypothesis, position of stock prices through the year will determine their performance with a spotlight on the volume traded. When you are analyzing a stock, you have to analyze the stock at the price at every point in time and the volume traded, which relates to the interest of people buying it at every point in time. So our stock would be a temporal analysis between 2011 and 2021, with all the years in between in review. So this chart attempts to compare the historical and present status of 9 stock prices. So what are the 9 stock prices? Apple, Starbucks, Facebook, Advanced Micro Devices, AMD, Qualcomm Incorporated, Tesla, Zynga Incorporated, Cisco, and Microsoft. All these are stocks that we analyzed in the following charts. So this is for the Advanced Micro Device trade volume between 2011 and 2021. And for the light green bar shows the maximum of high, and the purple shows the minimum of low. So this shows the price of stock at every year at the least price you can buy it and the highest price of which you can acquire the stock from 2011 to 2021. This is for AMD. And the chart analysis, the peak here of the chart of the stock is 2021 with a peak price of $122 and a low price of $72. Thus, if you're making a 10-year investment from 2011 to 2021, you will make a profit of between $68 and $115. If you're making a short-term investment of a 5-year, from 2016 to 2021, you realize a profit between $71 to $110. Next, Apple stock data. And this shows the prices let me move to the chart analysis. For the Apple stock data, the peak here is 2021 with a peak of $115 and a low of $116. That means if you sell at the highest price that you can from January to August, you will sell at $151. And if you are selling at the lowest time, you sell at $116. So if you bought it in 2011, you make between a profit of $104 and $137. And for a short-term investment, like we did earlier, from 2016 to 2021, investors will make a profit of about $89 to $122.
Ola, you have less than 1 minute. Hurry up.
Okay. Let me just move to these are the charts. So stock performance summary. Over the chart that were shown, Tesla is the best stock to invest over a period of 10 years. This is also the best stock to invest over the 5 years window. And the worst stock to invest in is the Zynga Incorporated over the years. And investors that jumped on the stock, on the Zynga Incorporated stock in 2012, will have amassed a high loss in 2021. And the loss is about $50. If you bought Zynga Incorporated stock in 2012, you will have made a loss of $50 over the stock you purchased. And this is the volume traded by year. And this is the analysis. We did a Google trend analysis to show the interest of people in the stocks over time. We compared Tesla, Zynga Incorporated, Apple, Microsoft Corporation, and Cisco. And you can see that Tesla is the most talked about web search over the past 12 months, followed by Apple, then Microsoft. Zynga, like I said, it is the worst stock to invest in.
Your time is up. Just round up.
Okay, so of all the analyzed stock, Tesla possesses the highest volume in the years. This can be attributed to performance, which drives an affinity for the purchase. In simple terms, investors are readily interested in acquiring Tesla stocks. Notably, Qualcomm and AMD experienced high trade demand in 2019 and 2020 due to their low prices. So people are acquiring it for futuristic trades. So recommendation, which stock should I invest in? Investors should endeavor to acquire Tesla stock as they are in demand in the stock market. They also have the societal buzz that aids resale. Facebook, Microsoft, Starbucks, AMD, Apple, and Qualcomm are all great stocks to invest in. Although gradual, there has been a consistent upward trend in their prices through the year. So if you are looking to make your money very fast, invest in Tesla. If you are looking to make your money over lots of years to come, the following Facebook, Microsoft, Starbucks, Apple, AMD, and Qualcomm are good stocks to invest in. Thank you for your time.
Thank you very much, Baderian. That was a really good presentation. I, for one, am looking to make some money, and by your advice, you're saying I should invest in Tesla, right? And I'll get my maximum return.
Yes, you get over $900.
I'll take you up on that. Thank you very much. Over to our judges. Do you have any comments?
So for me, I like the presentation. So I don't know. Are you supposed to build any models or just an analysis? That's the question I have. Also, I like the chat. Yeah, the chat was nice actually. I actually enjoyed the presentation. It was too fast though. I guess that's because of the time constraints. Yeah, so my single question was that are they supposed to build any models or just based on analysis? Yeah, thank you.
Oh,
yes.
But anyway, I believe that question is for you.
We are just to make recommendations on financial stock performance. The major overview of the project was that people are increasingly getting interested in investing to make more money. So what can data analysis do to help people to invest in the right stocks? So it was basically analyzing stocks and making recommendations. That was the overview of the project.
I think that was good, like Godwin said. My question would be more that what kind of models did you build for future forecasting? Like, I mean, everybody can look back and say like, oh, I should have done this, I should have done that. But if you're looking into the future, you need to have a model that will predict it with a certain level of certainty. So my question for you is like, what kind of models did you guys use, or did you just stop at the analysis? So I want to discover the next Tesla. I want to discover the next Starbucks stock. And they love that right now that you look back 10 years from now, I was like, oh, why didn't I buy this stock? So my question for you would be, what kind of models do you use to like do all these analyses? And what kind of new insights do you think you can derive from all the companies I just starting right now and make a recommendation for me, so that if I can afford Tesla right now, maybe there's a $10 stock I can buy that will be $10,000 in 10 years.
Okay. Basically, for if we had time to show all the charts, there are some stocks that you can buy if you are let me say a mid-level earner and you don't have much money to acquire Tesla, because a Tesla stock goes for higher than $1,000 right now. So we could have shown stocks that people with little or less funds can acquire. Also, to make recommendations based on people that, okay, for now, I just want to start investing in stock right now. That was why we employed the use of Google Trends. Google Trends will talk about, would give us an insight about the stocks that people are really talking about right now. That is based on web search, based on keywords used, based on AdWords used. So that is why we included the charts from Google Trends. So if you're not buying Tesla, if you're not buying Microsoft, if you're not buying AMD, there are other stocks you can buy, like, though included in the charts. I want to just open my book. Like Cisco stocks are at low ends, and they are being talked about at the moment. But right now, people are jumping on the best stock. So you can't compare the way the buzz about stocks that are really not performing very well to Tesla, because it has the buzz, it has the price, it has the trend. That's all I have to see.
Okay. I'll be more interested in your analysis. So if I can see the Jupyter notebook or whatever you do for your analysis without that, I think that'll be helpful. Yeah, but good job. Thank you.
Yes, sir.
Thank you very much to our judges for your insights. So our next presenters, we have Analyst O2. He worked on anomaly detection. We have Taiwo Oladapo and Samuel Pagbami presenting Analyst O2. Yeah, I can hear you, Taiwo. How are you doing today?
I'm good.
All right. Are you ready to take the stage?
Yeah, I'm ready. Yeah.
All right. Time starts.
This is my screen.
Yeah.
Can you see my screen like this? Hello?
Yes.
I
Yeah.
think you can start twice loading.
Yeah.
Can you hear me very well?
You can proceed like this, Taiwo.
All right. So I'm Charles Adity. Good afternoon, everyone.
Good afternoon.
So
I think there might be some problem with your connection or something.
I think we lost Taiwo. All right. while we try to get Taiwo back, I'm moving on to Analyst 03, HR Analytics, represented by Obina Ikoku and Kelvin Agbonde.
Hello, hi. Can you guys hear me?
Yeah, I can.
Okay, let me just share my screen. Really sorry, just hold on. Can you see my screen?
Yeah, please proceed, Obina. You can see your screen.
All right. Okay. Where's that? All right. So good morning and good afternoon, everyone. My name is Obina Ikoku from Analyst Group 3 of Hamoye Summer Internship. I'm the project leader of our group. I and my partner, Mr. Kevin Obonde, have carried out a project on HR analytics, analyzing employee data of a case study company to better understand the high attrition rates and recommend suitable solutions to reduce and maintain lower levels of employee turnover. Hope you enjoy our presentation. And due to the confidentiality of employee data, we use a case study company. So just to move on, what is HR analytics? It's defined as the area in the field of analytics that deals with people analysis, applying analytical process. Can you hear me?
Yeah, we can hear you, but you're not sharing your screen.
Okay. Can you see it now?
Yeah.
Okay. Let's just do this one time. All right. Like I said, HR analytics is defined as the area in the field of analytics that deals with people and analysis, applying analytical process to human capital within the organization to improve employee performance and improve employee retention. Okay, so essentially it provides evidence-based HR research and analytical insight to help organizations achieve strategic objectives. Okay, so he has really sorry for this. Various uses, discovering underlying reasons for employee attrition, improving employee performance, identifying factors that lead to employee satisfaction and productivity, determining and recruiting selection process, establishing effective training and career development initiative, and especially when not to. There's been a lot of debate. It's more HR departments have to have a follow the leader problem. That is simply because they copy HR practice set by industry leaders and believe when operating at this benchmark, they are doing a good job. But with HR analytics, we can now custom tailor HR practices to suit the needs of the company based on the operations. And this is definitely more effective than just using general HR practice. Business question and data set. Our data is gotten from an online data source website called Kaggle. The link is provided in the slides. The data is based on a case study company called XYZ. Their aim is to maintain an employee headcount of 4,000 people, but lose 15% of their workforce yearly. Employees living within the first year are considered bad hires and have several negative consequences in the company, such as a sizable department has to be maintained for the purpose of recruiting new talent. More often than not, new employees have to be trained for the job and given time to accumulate themselves to the company. And projects get delayed. So this is bad with clients and partners and what have you. Hypothesis is we hypothesize that income was the main contributing factor to the company's high attrition rate. No hypothesis is income had no relationship with staff leaving the company. Here we just made a quick dashboard of our data to visualize it. And employee headcount was 4,410. The HR metrics used was 19. Average age of employee was 37. Average years at company was 7. Male to female employee ratio was 60% to the males, 40% to the females. Attrition by department was research and development had the bulk of the attrition by 65%. Sales had 30%. Human resource had 4%. But we can see here the average monthly income per year. We can see here that the monthly average income seems to start decreasing from year 4. but sees a slight increase in year 6, but the drop again in year 7. So that might explain why the average time spent at the company was 7 years, but we, move further down. So here's attrition by age bar chart that shows people ranging from the ages 27 to 31 are the ones that left the company the most. Right below is attrition by gender. And we can see that more males left the company than females, but factoring the fact that females only make 40% of the workforce, attrition is very high comparative to males. Fortunately, we didn't visualize average amounts received by females employees comparative to males to get an insight if there was any gender pay whatsoever. Here we did a correlation heat map.
Obina, you have less than 30 seconds. You have less than 30 seconds. Wrap it up.
Okay. So here we did the random forest classification. It gives us the ability to precisely classify observations, and is extremely valuable for various business practices. First, we have to split the data into 75% for training, 25% for testing. Training data sets is used to train models, while the test is used to test performance. The result of the accuracy of a model came back 99%. And in this slide, we use the Confucius matrix to further predict the accuracy of our machine learning classification. Here we see our model accuracy to be 96%, identify 96% of the employees that left the company. We then use algorithm to find which metrics our model visualized to, which our model visualized as the most important. Here's the visualization of importance. And we can see here that it wasn't income, which that ultimately says that our hypothesis was wrong. It states that yes, the current manager was the major cause of our attrition. So followed by marital status and stock options. Then we gave some recommendations for that. So we said that the employer should allocate funds for training managers on how to better handle employees, employee bonding traits gatherings, focus on career development of staff, and increasing stock options after working 5 years at the company. That's the end of my presentation. Thank you for having me.
Thank you very much, Johnson.
Right.
That was a good one.
Sorry
Over
for
to
rushing.
our judges. No problem. It's fine. Over to our judges for their comments.
My observations are on these slides. I noticed one, you're reading from your slides, so you want to reduce that. So you want to reduce that. If you're going to be reading from this slide, you don't need to then there is no need for giving us this talking. So we can all read from the slide. So you want to reduce that. Secondly, the slide animations. If you are going to do a presentation like this, you need to make it simple. Since you know your time is short, so you have to make it simple and make it fast. So you don't want anything that is going to reduce or take away any second from you. And thirdly, I suggest maybe next time if you want to do a presentation, instead of putting on too much words on the slide, at least make it put some images there that describes what you're trying to explain.
Okay.
Yeah. Then fourthly, your analysis. You want to only highlight what you want to show your audience to see, not like putting out everything out there. You want to give us like what you only want us to see. For example, when you went to the slide where you're giving us the HR analysis, you are struggling to like identify which part of your graph or your bar chart was going to tell us what you want to tell us. Next time you try to highlight only that particular chart you feel is important to the audience.
Okay.
You feel me? Yeah. So that's all from my end.
Yeah, man, I think Godwin nailed it like a pro. Basically, those are like soft things that you don't normally. Your presentation is great, but you need to think about your audience as well. And the fact that we're not in the same room with you, there's bandwidth problem, there's latency due to internet. So even though all those animations are cool, but you want to like tone it down and just go straight to the point, show the graph, and not just focus on things that are not necessary. We have limited time. Think about it like you're trying to build a startup or a company, and you meet an investor in the elevator that is going to floor 10. You need to show them what you're doing and be able to convince them within 2 minutes. And if somebody is not buying what you're saying within 2 minutes, that means you're not doing something right. So you need to go straight to the point, not too much details. Focus on the core aspects of your analysis and your presentation work. I think that's very key. And it's you guys did a great job, but it's something that you tend to understand over time as you do more and more presentation, because people see in pictures. That's why when you drive on the highway, you don't see them typing text, they use pictures. That means people have a low attention span. When you show them something in a picture, they get it right away. But if you're using a lot of text, then it becomes cumbersome for someone to read through. I'll be honest with you, I didn't read all those texts because it takes a while to just process all those things. So I just want to go straight to what you're doing. See the graphs, see the gender differences due to attrition, see the reason why people are leaving. So you need to ask what problem are you trying to solve? Why are you trying to solve it? And the proposed solution. So you only go through those 3 steps super fast. So, but back to your stuff in terms of all your analysis and stuff like that. Can you flip back real quick to the Jupyter notebook so that we can see what you did and just talk a little bit about it? I know you were rushed off that point. If you can just talk a little bit about your analysis, which is what I'm really interested in, and just show us your algorithm. Yeah, just go through those 2 slides.
Okay, so basically we just did the random classification model, which is supervised machine learning. We just use that for our predictive model. Just first of all, split our data into 2, as you can see here, and just to basically just classify, our data for the attrition, because we had to change it from it was a yes and no, so we had to turn it into numbers basically, and then we now run the classification model and did the confusion matrix as well, just to get the accuracy of our model. You can see here we got 99%, and then we moved over here and we got 96%, and then afterwards we now visualized the importance of our model, just to see which metric was the main determining factor in why people left the company in the first place. From the research that we got, from the feedback that we got from our model, the hypothesis we made about monthly income actually came right up in the middle. But we can see that, years with current manager was the major reason. And if we actually go back to the charts I showed earlier, I didn't really have time to go through my correlation heat map, but I saw a lot of correlation between the years at company and years since last promotion. So I saw obvious obvious signs that managers or employees staying with managers for a long time and not seeing any sign of growth, and in terms of their position, and seeing slight decrease in their income as well, might have been the main reason for leaving the company. So like I said, we then did these models to test everything, and based on our data, 95, 99%, 96%, which was very, very accurate. So based on that and the level of visualization of our importance, we just came to this conclusion that, instead of focusing on income, we should focus on managers and how they handle employees, bonding trips and career development for staff to, reduce that high level of attrition in the company. Do you understand?
Okay. Yeah. Can you go to your correlation plot and just look at all those attributes and see what correlates with each other? If there's a correlation between one, just explain it in terms of the correlation plots.
Okay, a correlation, here we see a positive correlation between age and total working years at 68%. And then we see a positive correlation of 62% between years at company and years since last promotion. Where is it here? Right here. And then most importantly, we now see the correlation between years at company and years with current manager. Here at 77%, years at company, years with current manager. So we just
I'm just trying to understand that and let everyone try to understand it. So if I spend more time with my manager, same manager, and I'm not getting moved around, I'm more likely to stay at the company, right?
So you're more likely to leave, because we could see here that people really left because of that reason. Is that when they stayed with the current manager for a long time, there seemed to be a halt in the way they progressed in their career. Do you understand? Okay. Yeah. So they just left the company because then their salary also stayed stagnant or even started reducing as well. So there was no need. And that really explains why here the average years at the company was 7 years. And sorry, another thing I didn't mention in my chart is the attrition was the people that left the company were from age 29 to 31 as well. So I don't know if the company has to look into that too. But like I said, based on our data and our findings, it's more about the manager and progression in career than the monthly income.
Okay. So if I have a good manager, I'm going to stay in the company. If not, then I'm more likely to leave.
Yeah, if you have a good manager and there's clear signs of career progression, instead of just staying in the same position for years and seeing salary decrease. So just promotion essentially, and a clear path for career development.
Upward mobility.
Yeah.
All right, cool. Thank you.
Thank you very much, Obina. That was a good one.
Thank you.
On to the next group, we have mineral prediction. This is a machine learning work, by the way, by Sumitra Saravani, representing D-Science 01. Sumitra.
Yeah, hi. I am going to share my screen. If my screen is visible. Hello. Hello.
Yeah, please go ahead. We can see your screen.
Yeah. So, greetings everyone. My name is Sumitra Shawnee Singh, and I am representing the group Data Science Group 1. And we worked on this project called Mineral Prediction with Deep Neural Networks, particularly gold. And these are my team members. So why we actually did this project? So mineral industry is a big time industry. So, but exploring minerals is a very difficult process. It takes a very long time. So basically the earth crust, as you have seen on the slide, it consists of 2.5% of Earth's volume. But as per geological surveys, people say, like geologists research, there are only like 95%, only 10 minerals occupy 95% of them. So but we could, only 25% of minerals has been identified from the 2.5% of Earth's volume. So we just want to know we believe that there are many minerals, and in order to overcome this problem, there are many satellites nowadays which we can use, and we have just used this satellite data along with our neural networks to train this model. So we use pre-trained convolutional networks to predict the particular mineral gold in a particular region. Why gold? Because we can only find the gold TIFF images from South Australian department, where we have downloaded the data from this site. So the data acquisition, we have collected the data from Aster. It's an open source satellite resource, and SARIC, it's a tool of South Australian department. So these are some of the screenshots of the data we have collected. As you can see, we have collected the data TIFF images. And this is a shapefile, which I'm going to explain in the later slides, why we have, what are the shapefiles and what is the indices of my minerals. So what is actually Aster? Aster is an open source satellite image, advanced space thermal emission radiation. The full form of this satellite it's a multispectral satellite image source. So this satellite, we are actually having many satellites which can provide us this prediction of minerals all over the world. But we have chosen Aster because Aster actually provides manipulated and stitched data image formats. So this actually gives us a mineral resource locations on and under the ground also. So what actually did for finding the mineral gold, we should be having 3 mineral indices actually. So we can't directly find the gold mineral. So in order to find the gold mineral, we have to go through this. We have to look after this in mineral indices, whether they are particularly present in that area or not. So for finding gold, we are having OH bearing minerals, KLI, ALI, and calcite. So we have collected this data from Geoscience Australia, Aster Geoscience Maps. They actually provide the stitched data, like ready to use image formats. So in order to download, we cannot, because downloading the raw data from satellite is quite a huge Herculean task, because there are many real world problems like cloud coverage and all. So fortunately, the Australian government has provided us these images. So we have downloaded a bunch of images corresponding to these indices, AIOH, MGOH, and kaolin. And then we have a lot of images, but in order to train the model, we have to give the images containing gold. So we have used the tool called SARIC, South Australian State Department. They actually provide a bunch of minerals and mineral shape files and mineral deposits where a gold is present and where gold is not present. So this is a roadmap what we actually did. We have collected the data as I have already told, and we did a data processing and then used a pre-trained convolution network, a transfer learning for actually visualizing. And then we again use those feature vectors and then classified these predictions using some ML algorithms and then use some performance metrics. So how we did the data processing? For data processing, we used a Python inbuilt library, which it's called GDAL. It actually works with the geospatial data abstraction, geospatial data. So this GDAL, it actually exported the info of this mineral shape file where the mineral deposits are present, and it actually sliced the data image formats into the appropriate sizes we wanted using the contents of AIOH, MGOH, and kaolin. So other than this actually produces a false color image. After exporting the data, we will get a false color image. A false color image is nothing but providing more than red, green, blue bands. We are having much more colors like pink, etc. for different minerals. So this is a false color image as you can see on my screen. We are having a red, green, blue, as well as some pink dots over there, which actually corresponds to different minerals.
Sumitra, so you have few minutes left.
Yeah. So after generation of the false color image, I actually trained my given this input image to the ResNet 50. It's a pre-trained convolutional network. So and collected just a feature vectors from it, and then used an Apache Spark. We can also use different separate algorithms like SVM, and we can train the model. But I used Apache Spark because it is a cluster of many algorithms, and the work is made easy. So in order to use Apache Spark, I have to convert this false color image into libSVM format. What is a libSVM format? It actually gives a binary number for classification, like filtering gold and non-gold samples. And so we are having only like gold samples, and non-gold samples are very less. So I oversampled the non-gold sample ones to give a balanced data of it. So this is a model processing, a false color image, then ResNet 50 to generate the features, and then used a classification to predict the algorithms. And then this is the accuracy. I have used only like logistic regression, SVM, and naive base, and the accuracies, as you can see on the screen. And then I have used a performance metrics like recall and precision. For me, precision is very important, as well as recall also. So both when compared to both three algorithms, SVM, it actually gives a good response with 80%. So you can see on the screen, there is a red color image, and then is a boomerang kind of shape. So the red color is like non-gold, and the boomerang shape is like there are gold deposits over there. So I use the QGIS tool to work on this, and on the base map, I just found that the location is a mineral deposit in Australia. Yeah.
Sumitra, please round up. Your time
so this is the conclusion. Yep. Yes. So the conclusion is like SVM actually performs well on a stitched data. We can also use raw data, and we can build our own neural networks with the satellite connectivity. Thank you so much.
Thank you very much, Sumitra. Over to our judges for some comments.
Charles, can you go first?
Oh yeah, I'll go first. I think this is very impressive. I think it's a good presentation. Can you keep the slide back on so that we can cue back into it and just
yeah, sure.
Cycle through things. So obviously you're dealing with image data, you're processing it and everything. I saw you're grabbing it from the FTP site. What challenges did you face in terms of solving these problems? Because I know it's compute intensive. I've used a GDAL before to like extract stuff. Can you just walk through the process of your data preparation and all the things that you did in basically processing the .cif files and all those things?
Yes. So these are the images we have downloaded actually from the FTP site. So these are the TIFF images with the band. You can see like MGOH, AIOH, and kaolin group band images. So these are very important for predicting gold. These we can easily download it from this site. And this is the mineral and shape file, which we have downloaded like South Australian department, where the gold is present, where the particular mineral, like not only gold, and many minerals, where the shape file is this. And then I have used a libSVM format for Apache cluster. So further, I have mentioned the indices here. Like as you can see, alunite is 1, PTM 2, and gold is 3. So I have the gold mineral index is 3. So the process goes like this. So first I have processed my mineral. Processing the minerals is done using the mineral and shape file. And then I will get a command file consisting of 3000 TIFF images containing gold and non-gold with all the bands. And after that, I have fed this images to ResNet 50 architecture. So I had trained before totally giving the prediction, like I don't want the total prediction. I just cut it out to get only just a vector features of my image, false color image, and then use those vector features. And then I have and converted them into libSVM format, into binary format. I just filtered the gold examples where the images where there is gold and where there is non-gold, and then used these algorithms like logistic and SVM and naive bias. But we can also use MLP and many other neural networks also.
So you say you use ResNet. Can you talk a little bit about why you use the ResNet? I just want to understand what you're doing out there.
Yeah, not only ResNet, we can use VGG16 inception module, but I have chosen ResNet out of my own interest. There is no like particular reason for that.
So whenever you're training a model, especially because it has to do with images, right? So you're using ResNet, which is a neural net. So, and you talked about the input vectors. Can you explain what that input is? I just want to understand it, and I want everyone on as well to like understand what you're doing.
Yeah, the false color image actually. So the false color image, this is where we get when we process the data. So in order to find the vector features, the features are like the model should only identify the features containing AIOH, MGOH, and kaolin index. These are the features we want. Means the model should identify, okay, this is a particular point where AIOH, this is a color of the AIOH. Suppose AIOH is a red color band, MGOH is a green, and kaolin is a blue color band. So the model should identify those bands and identify those features, and use those features in order to predict the classification of gold in our next machine learning algorithms.
Okay. So you have a set of images, you have different bands. So you use those bands to convert them to vectors, and you fit in the vectors to your ResNet model. And once you have your ResNet model out, you can now use that model to predict if you show it another image, right?
Yes, to show that whether there is a particular mineral gold, not only gold, because for gold it is like AIOH, MGOH, and kaolin. For like some different minerals, like suppose for example, we can take copper. We can't find directly copper. There are like some mineral indices related to that where copper should be found. So copper, we have separate mineral indices and separate image bands.
Okay. All right. Yeah, I just want to be clear about that because you didn't emphasize it in the slide. So, so now you've trained your model and you have your model out. You want to predict, you want to evaluate the performance of your model. So you have a metric. So can we go to your metrics and just talk about the things that your metrics are producing? Because that's how you measure how effective the model is. So just talk through all the things you did there and let's know how it works and what you did.
Yeah. So the accuracy, the metrics is like recall and precision. So recall is like whether out of the total gold images present, how will my model identify the particular gold images. So in that, like I got this SVM 0.23 because in testing the model, I didn't double the, actually, I didn't oversample the images for testing, like because my images are very, very little. So it consists of more gold and less non-gold images. There are some differences over it by training the model, but I just took over the accuracy thing and the precision thing, and both SVM has performed excel other than this logistic and naive bias.
Okay. So which is a key? Are you more interested in the precision of the model or the accuracy of the model?
I'm actually interested in this both recall and precision. Accuracy, we can get it easily, but performance metrics are very important when training the model. So as I don't have the sufficient data, I think I'm more interested in recall and precision both.
Okay. Thank you. Godwin, do you have questions?
Yeah. So okay. So my question is on the choice of Spark. The choice of Spark. Why did you go with Spark rather than Pandas?
I feel it's like very, for me, I have worked on this before, so I just go and do it. It's a cluster of many algorithms. I just need to write a few lines of code. That's it.
Okay. So another question. So this on the performance of your model. You said yes. So seeing the performance of your model now, I'm curious. How do you think you can improve on the scores here?
Oh, pardon, I didn't get you. Sorry.
Okay. So based on your performance, your model performance now, how do you think you can improve the model performance? Maybe like a higher accuracy, precision, or recall.
Yeah, I actually look out at mainly into this. I just look it into the accuracy only, as I don't have many images. So if I have good amount of images, then I will look into the performance metrics, mainly recall.
Okay. Cool. Nice presentation. That's all from me.
Thank you very much, Charles and Godwin. Permits me to bring back the last group that we lost due to network issues. Analyst O2, Anomaly Detection, by Taiwo Oladapo and Samuel Pagbam. Taiwo. Hello, Taiwo.
Yeah, I can hear you. Can you hear me?
Yeah, are you good to go now? Have you sorted out every issues you're having?
Man, the network is still bad, but we'll try. Yeah.
All right. Remember, you have 5 minutes, so try and wrap up everything before that time, under that time frame.
Yeah, I'm presenting on healthcare medicine anomaly detection. So these are the presenters. These are the group members. Sorry. Then the overview of this is the healthcare fraud is considered a challenge for many societies. Healthcare funding that could be spent on medicine, care for elderly, emergency room visits, instead lost to fraudulent activities by materialistic practitioners or patients. So with rising healthcare costs, healthcare fraud is a major contributor to this increasing healthcare costs. So what is anomaly detection? Anomaly detection is a step in data mining that identifies data points, events, observations that deviate from a data set normal behavior. So the aim is using the visualization trends to find the anomalies in the data. So we got the data from Cargo. So this was the visualization trends for we got 499 total number of healthcare providers. So 143 female provided data, 356 male provided it, and the number of credentials of provider was 56. So this was the index of provider. We got internal medicine as the highest provider, and pain management was the lowest provider for the detection of the anomaly. Then we have another one, which is to show us this is showing us the amount of provider type, which is internal medicine. Then we have the diagnostic, radiology, and the list was pain management. Then this is showing us the gender of the people that donated the data, which is showing us the male donated 70.67% of the data, while female donated 29.83% of the data. So we have the average medical payment account, which is we have two HCPC drug indicator, which is N and Y. And this is showing us the male and the female medical payment. So this one is showing us the average. This is showing us This is showing us the average medical. Okay, this is showing us the city of the provider, and which is New York provided the large number of data, followed by Philadelphia, Saguenay, Troy, and the list was Fairfax. And this is showing us the average medical alert amount, the average medical payment amount, the average Medicare standardized amount, and the average submitted charge amount. So my conclusion concerning this is controlling the rapid escalation of healthcare costs while extending health insurance coverage to all. The primary objective of healthcare reform is to maintain and improve health and well-being, to make basic health coverage universal, and to encourage the efficient use of limited resources.
Thank you very much, Taiwo.
You're welcome.
Over to our judges.
Okay. So thank you for your presentation, Taiwo. Nice one. So yeah, I'm going to be repeating what I told to Obi now. So your slides, I feel you're telling a story. There's a lot of story that's being lost here. Like yeah, there's a lot of story that's being lost here. His slide wasn't like representing what you're explaining to us. It wasn't telling that story perfectly yet. I think you can improve on that. Yeah, Charles.
Yeah, I think that was a good call as well. Making sure that your slide tells a story and goes straight to the point. Especially since we're virtual, so you just want to be able to like go straight to the point of what you're trying to do, the what, why, and your proposed solution and your conclusion. So, and try to be as visual as possible. So, but my question would be more towards your model. Is it? I don't think you did any modeling out here. Is it more what you've done? Is it more around the data analysis? Do you have any prescription models or any prescription models that we've implemented that we can look at and see?
No, it's not. It's not.
What?
So no, what did you, I didn't get. What did you say?
Yeah, I said most of your work is centered around the data analysis. Do you have any prediction of model? I just want to see your model or any kind of model you implemented for this.
No, like I just used the visualization trend for this. I didn't use any model.
So you're just doing data analysis and visualizing your data.
Yeah. Yes, that's what I did. Yes.
All right. Okay. Cool. Yeah, I think that's it from my side. I don't think I have any questions. Thank you.
All right, no problem.
Yeah.
Thank you very much, everyone. That was a really good one. So over to Charles and Godwin. This is like a recommendation, like kind of like a question thrown towards you. And I kind of need your input on this. So one of our interns made something like a suggestion about, okay, so I'm going to read in quotes what the person said. So my suggestion would be for other capstone projects, there should be more time for the team to share their works and insights, even if it means extending the session to 2 hours. I feel it is important to enjoy the hard work through calm presentation, which will mean giving them at least double the current time. So I don't know, this is like a suggestion. So in your professional capacity, do you think this presentation could be done under the space of 5 minutes, or we should make room for allowance for more time so they can actually show us what they worked on? Mr. Charles.
I think it's both ways. You want to be able to like express yourself succinctly. Like if I have a time, but I mean, I've been doing this for a while, so if I have a time, I will have used it a lot more efficiently than what most people did. But at the same time, I would be interested in spending more time so that we can deep dive, go into each section of the slides and talk about it, because when we're doing all these things, you're not just presenting. We want people to learn and be able to ask questions. So while the presentation is going on, somebody other than me might have a question that I'm not really catching. So I want them to like put a question out there so that way I can learn from them, and we can all learn from each other. So it's good to extend the time, but I think subsequent presentations, we should still all be disciplined and be able to like go straight to the point. So, I mean, reduce all the text and all the verbiage. I'm not going to read your slides and read the text on it. I just want you to go straight to the points, use images where possible, be very visual. It's easier a picture is what 1,000 words they say. So, so be more efficient on your time utilization. That will save to everyone. And I think it's okay to like extend the time so that we can just poke through a little bit more, ask them some more like detailed questions around what people are doing, and we can all learn, which is the whole purpose of this thing, so that we can learn from each other.
Thank you very much, Charles. So do you have any final recommendations for our interns, any pointers of what they could do better next time?
Pointers, which is kind of like a sequel to just what I just said. Be more organized in your presentations. You understand, like, define the problem. Why is this problem existing? What's your solution and your conclusion? and you want to like just go through it, bam, 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 and be able to like explain things succinctly. I think it's very important because a lot of people understand how to do cool things, but you need to be able to like sell yourself and sell what you're presenting to other people. So I think that's very key and that's very important. So I think subsequently on what you guys are doing, just focus on all those things. You need to understand the problem, define it at the start, show why you're solving it and the solution you arrived at and your conclusion. I think those things are very important. So other than that, I think you guys are doing a great job, and I'm looking forward to subsequent presentations and what will come out of this.
Thank you very much, Charles.
Yeah.
To our interns, I want to extend my gratitude to you. You put in so much work to bring us this presentation today over the past few weeks, and it's been really nice. I saw so much dedication and hard work you put into this. And I must say, I, for one, I started this afternoon on a sad note. For coming to this presentation, I can say my mood is highly lifted. You guys made my day. Thank you very much. And to Mr. Charles and Godwin, thank you very much for gracing us with your presence. Mr. Charles, I know how busy you are, and you took time out of your busy schedule to come be with us here today. Thank you very much. And it's always a pleasure to have you here as one of our judges. Thank you. So to everyone, have a nice day and enjoy the rest of your